Hey there, y'all. It's Miss Campbell, and today we're going to be going through our review of coordinate geometry and polygons, quadrilaterals, all that fun stuff. So first we're going to start with angles inside a polygon. And we had a formula that we used for this. So the formula is, and this is for the sum, okay? The sum, the formula is n minus 2 times 180. So if they ask you to find the sum of the angles in the polygon, that's what you're going to do. And remember, n is the number of sides. So if you get like 1 or 2, you just count the sides, and that's n. If you get a problem like 3 or 4, you just look at the number right there. So I'm going to do number 1 with you all. So how many sides does this have? 1, 2, 3, 4, 5, 6, 7, 8. So n is 8. So to get the sum, we do 8 minus 2 times 180. So 8 minus 2 is 6 times 180, gives us 1080. So if they took all the angles inside here and added them all together, it would add up to 1080. All right, our next kind here, it says find the measure of one angle in each regular polygon, okay? And the fact that it's a regular polygon, we can do that because regular means all the sides are the same, which means all the angles are the same. So I'm going to look at number 6. And the formula for this one, well, if we have n minus 2 times 180, that's the total of all the angles. But I only want 1, so I have to divide by how many angles I have, which is n. So number 6 here, I can see I have 1, 2, 3, 4, 5 sides. So I would do 5 minus 2 times 180 and divide that by 5. So 5 minus 2 is 3 times 180, okay, and divide by 5, we get 108. So each one of these angles inside this pentagon is 108 degrees. Okay, the next kind that you might see is like number 9. This is an irregular polygon because you can see the sides are different lengths. Also, these angles here are all different. A regular polygon has same sides, same angles, but an irregular polygon has different sides, different angles. So to find x on this one, basically we have to figure out what the total of this needs to be. So you have to do n minus 2 times 180. Okay, and so here n is 1, 2, 3, 4, 5. It's 5. So we do 5 minus 2 times 180. And so that would give you 540. So I know that all 5 of these angles here have to add up to 540. And so now I could write an equation. I do 124 plus 118 plus 100 and 100 plus x equals 540. I know on this one you're just like, well, I can add up the 4 and subtract from 540. Well, that's what you're doing here with the equation. But they might give you something more complicated on our test, so I want you to understand. You add the angles and set it equal to what the total should be, and then you solve from there. Okay, so now we're going to move on to quadrilaterals. Okay, and proving if they are parallelograms or determining what kind of quadrilateral they are. So there's some different things we have to remember. For a parallelogram, remember, so parallelogram, okay, the opposite sides are congruent. Your opposite angles are congruent. Your consecutive angles add to 180. And then your diagonals bisect each other. Okay, so that's parallelograms. And then we got rectangles. Remember, rectangles have everything that a parallelogram has. So all of parallelograms. But there's a couple of different things that are special for rectangles. First off, their angles, their corners are all 90 degrees. So they're right angles. And then their diagonals are congruent. So one diagonal is equal to the other diagonal. So that's rectangles. Then we'll go on. Our next one is a rhombus. Okay, for a rhombus, it has everything that a parallelogram has. So all of parallelograms. But then there's a couple things here. Your diagonals are perpendicular to each other. So your diagonals make right angles. Okay, remember that word perpendicular. And then your diagonals bisect the opposite angles. So they bisect the angles on the corners. So I'm just going to say they bisect the corners. Okay. And then now a square. Okay, squares, they have everything all about a parallelogram. Everything about a rectangle. And everything about rhombuses. Okay. Okay, and so on a square, you have a lot of things that are equal. So on a square, we have our four corners, they're all 90. Okay, your diagonals are equal to each other, and they're also bisected, so you get these four little equal pieces. Also, your diagonals are perpendicular to each other, so they make right angles there. And then since a square is also like a special kind of rhombus, these corners here are bisected. I know I didn't draw my little right angles the best, but basically it makes two 45s on each side. Okay, so 45 and 45 because that 90 is getting cut in half. So that's the big thing with squares, rhombuses, rectangles, and parallelograms. Those are the main shapes they're going to really concentrate on. So now we're going to look over here and we're going to see, can you prove that the quadrilateral is a parallelogram based on the given information? And we have to explain. All right, so number 9, here we can see our diagonals are each cut in half, right? So this half is equal to this half, and this one half is equal to the other half. So could this be a parallelogram? Well, let's see. If it's a parallelogram, then the diagonals bisect each other, so yes, okay, because your diagonals bisect. Okay, then let's say you have something here like number 10. You got to be careful on that one. You see how number 10 says, like they give us two angles, right? They're opposite angles, they're congruent, right? But in reality, your opposite angles has to be both pairs, okay? Both pairs need to be congruent. On this one, they only show us one pair. So this one would be no, okay? Because only one pair of opposite angles is congruent. All right, move that a little bit. Opposite angles congruent. So then 11, 12, y'all will have to go through there. And again, you're looking for this one, 9 through 12, you're looking at parallelogram. Okay. Now on 20, I need to redo the numbering here. Sorry about that. On this next set, okay, you will have to look at, it says determine the most precise name. So you're going to need to look at all the little things that we wrote down, and you'll have to see what it matches. So number 20 here, all we see is that both pairs of our opposite sides are congruent. So like the top is equal to the bottom, the left is equal to the right. Well, we don't know anything about the angles here, okay? We don't know, you know, if the diagonals would be perpendicular. We don't know if the angles are right angles. We don't know anything. All we know is the opposite sides are congruent. So that one would have to be filed underneath a parallelogram. So you're trying to see, do you have enough evidence to put it in one of these categories? So for, oh, we need to add something. I had forgotten. On rhombuses and squares, all sides are congruent. Okay, so yeah. And on squares, yeah, you can just add that. All sides congruent. It comes from rhombuses, but anyhow. So here on number 23, right? This one, we'd have to classify it as a rhombus because we see the four sides are congruent, okay? Which would tell us that it's a parallelogram because top is equal to bottom, left is equal to right. So it's a parallelogram with four congruent sides, so that makes it a rhombus. Okay, parallelogram with four congruent sides. So that would be a rhombus. Okay. Now our next section, they're saying for what value of x is the figure given, the given special parallelogram. So they're saying if number 11, if this is going to be a rhombus, what would these values of x be here? Well, we can see we have a rhombus here and we have a diagonal. Well, what do we know that the diagonals on a rhombus do? They bisect this angle. So this 3x minus 2 would be equivalent to this 2x plus 16. So 3x minus 2 equals 2x plus 16. And then you would solve that for x. Okay, again, on number 12 there, it's a rhombus. So you have to remember what happens on a rhombus. What are these central angles here on a rhombus? What happens with the angles where you have a diagonal going through it on a rhombus? Remember here, it's going to create some right triangles, right? Because these are right angles here. Okay, so you got to kind of remember that and remember which angles are going to be equivalent to each other. So you can already figure out angle 1 there on number 12, since you know it's a right angle in the middle, and you know one of those angles is 20. Same thing here on a rectangle. Okay, number 13. If it's a rectangle, this diagonal is not cutting it in half. But what do you know about that whole corner? If it's a rectangle, the whole corner is going to be 90, right? So these two, the two pieces, should add to 90. So write an equation where you add those two expressions together, set it equal to 90, you can find x. All right. Parallelogram number 16. My hint for you here is to find y first, because on a parallelogram, these angles right here, the 5y plus 2 and the 12y plus 8, if it's a parallelogram, those have to add to 180. So just find y first. And then here, the 5y plus 2 and this 2x, those have to add to 180 as well. So find y first. Okay, and then our last kind that we have, or a couple of our last kind, sorry about that. Okay, here we have to determine whether these triangles are scalene, isosceles, or equilateral. Remember, scalene, no equal sides. Isosceles, two equal sides. And then equilateral is three equal sides. So all sides equal. Okay, and how do we find these sides? Well, we do the distance formula. So for the distance formula, and I know you can do the counting, the Pythagorean theorem type way on here, but I'm going to show you with the distance formula so you can, number one, familiarize yourself with that, and number two, have another way to approach these problems. So for the distance formula, what you do is you get your points. So I'm going to look at z, which is at -2, 0, and then I'm going to look at x, okay, which is at 4, 2. So I'm going to find the length of zx. So your distance formula, it's a square root of x2 minus x1 squared plus y2 minus y1 squared. And all of that goes in the square root there. So it doesn't matter which point you call x1, y1, and x2, y2. You just have to be consistent when you're plugging it in. So I'm going to call z x1, y1. And x is going to be my x2, y2. So I'll plug in. So I'm going to do x2, which is 4, minus, and then x1, which is -2. And yes, you have to have the minus and negative, squared, plus, and then we do our y2 minus y1, so 2 minus 0 squared. And now y'all can usually typically type this into the calculator, but it depends upon how they're going to ask you to do your answer. So I'm going to calculate the inside first. So we have 4 minus a -2. That's going to be 6. And when you do 6 squared, you get 36 plus, and then here 2 minus 0 is 2. And so 2 squared is 4. And so this would be, you do 36 plus 4, so it's the square root of 40. Okay, and then you can do the square root of 40, and you get 6.3. Okay, so that's the first side. So this side is about 6.3. Now you have to finish this problem. You need to find the length of xy, and then the length of zy, and then compare the lengths. And you see. So whenever you have the triangle problem, you're going to do the distance formula 3 times. Okay, now a refresher. If you're not crazy about the distance formula and they're not requiring you to use it on your assignment, well, what you can always do is you can do the slope for the lines here, and you'll see if they have like the same lengths on their triangles. So look at this one, zy. I go down 2, and I go over 1, 2, 3, 4, right? Down 2 over 4. Okay, look over here. Look at xy. We go down 1, 2, 3, 4. And we go over 2. Again, look, another triangle with 2 and 4. So at least it's isosceles, right? Look at zx. We calculated at 6.3, but let's say we wanted to do the counting. Well, I go up 2, and I go over 1, 2, 3, 4, 5, 6. So that was 2 and 6. So would that triangle have the same length hypotenuse? Not necessarily. What you need to do is we got to calculate here. Like we have to calculate at least one of these 4, 2, and make sure that it's not the same. So yeah, be careful with that, because some people will want to say, oh, well, the legs are different from the other ones, so they're not the same. No, you need to actually calculate it, okay? On this one, we can tell it's not the same because, 2 and 6 versus 2 and 4, they both have at least one common number. But better be safe than sorry. So calculate 2 squared plus 4 squared. This would be xy. Okay, 2 squared is 4, 4 squared is 16. So 4 and 16, that's 20. Square root of 20 is not equal to the square root of 40. So this one would be isosceles, because xy and zy are both square root 20. So this would be isosceles. All right, now here's the last kind. We have to determine whether this is going to be a parallelogram, a rhombus, a rectangle, a square, or none of the above. So y'all, to do this, you need the distance formula, okay, which is square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, you maybe could also use the midpoint formula. Okay, remember the midpoint formula, not square root, sorry about that. Your midpoint formula, it actually gives you a location, okay? It gives you an ordered pair. So you do x1 plus x2 divided by 2, and that gives you your x coordinate. And then you do your y1 plus y2 divided by 2, and that gives you your y coordinate. Okay, so the midpoint formula you have to calculate, and then that gives you a new ordered pair. Okay, so we have distance and midpoint, and then slope. Okay, guys, slope. You do rise over run. Now, I know we didn't use slope when we first taught this, but I'm going to show you how to do it. So you have like another tool that you can use. All right, and for if you're doing slope, you have to pay attention to sign. Okay, and parallel. If two lines are going to be parallel, they have the same slope. If they're going to be perpendicular, the slopes have different signs. And then their fraction is flipped. So an example of a perpendicular slope would be -3/5. The perpendicular slope to that would be +5/3. So different signs, and then the fraction is flipped around. Okay, so y'all, when we taught this, we said find the length of the four sides, find the lengths of the two diagonals. Okay, you can still do that. Lengths of the four sides, lengths of the two diagonals, and then you compare it on that chart that we showed you. You can also use the properties of those, the quadrilaterals that we went through earlier in this video. Now, I'm going to show you with slope, okay? Because sometimes I can make it a little bit easier for you. If the main thing for slope is you're checking to see if the opposite sides are parallel. And then if you think it's either a rectangle or a square, you're looking for the corners to be 90-degree angles. And then if you think it's a square or a rhombus, you're looking for the diagonals to make right angles as well. So a few things that you need to look for to prove one way or the other. So I'm going to look at number 5 here. Okay, I'm going to look at number 5. So I'm going to use slope to help me look and see if opposite sides are parallel and go from there. All right, so DA. To go from D to A, I go up 2, and I'm going to the right, 1, 2, 3. And this is counting by 1, so yeah, so up 2 over 3. So it's rise over run. So DA, and I'm doing slope here, is 2 over 3. Now I need to look at the side that goes with DA, and that's CB, and I need to go the same direction here. Okay, so from C to B, again, I'm going to see how I go up and over. So I'm going to actually go counting inside that quadrilateral here, but it's okay. We're just counting for slope. So we go up 2, and we go over 1, 2, 3. So 2 and 3. Okay, so right now I have one pair of opposite sides that are parallel, okay, and they're also congruent. So they're parallel, and they're congruent because I got the same triangle off of them. Okay, now I'm going to look at my other two pairs of sides. So I'm going to look at DC. Okay, so from D to C, I'm going to go down 1, 2, 3. So that's a -3. And I'm going to the right 1, 2, 3. So it's positive 3. Going to the right is positive, going up is positive, going down or going left is negative. So for DC, our rise is negative 3, and our run was positive 3. Now I'm going to go over here and do AB. Okay, look, I need to go from left to right, AB. So I'm going to go down and then over, right? So I'm going down 1, 2, 3. So that's negative 3. I'm actually going to draw my triangle the other way so y'all can see it here. 1, 2, 3, 1, 2, 3. So I can see I had to go down 3, and then to go from A to B, I went to the right 3 as well, right? So again, A, B would be negative 3 over 3. So did they follow the same slope? Yes. Are they congruent? Yes. Okay. So I'm going to actually put that slope triangle where it needs to go so you won't be confused there. So we went down 3, so that was our negative 3, and I went 3 to the right. Okay, so that's a little bit more clear. So our opposite sides are parallel and our opposite sides are congruent. So right now we need to check and see here if I have a triangle, I need to look at the lengths of the sides, right? So one pair of sides, we had 2 and 3 from our triangle. Okay, so 2 squared is 4 and 3 squared is 9. So 9 plus 4, that's square root of 13. And then on our other one, we had 3 and 3. So when you're doing the distance, it doesn't matter like the positives or negatives from that slope. So 3 squared is 9, another 3 squared is another 9, so that's a square root of 18. So are all of our sides congruent? No. So that gets rid of rhombus and a square. So no rhombus, no square. Now it's either a rectangle or a parallelogram. Well, to determine between rectangles or parallelograms, what I can do is I can either look at my diagonals or I can look at these corners here. What I'm going to do is I'm going to look at my diagonals. All right, I'm going to see how long the diagonals are. And if they're congruent, then it's going to be a rectangle. If they're not congruent, then it's going to be a parallelogram. So from A to C, I'm just going to count because it goes vertically, right? So from A to C, it's 1, 2, 3, 4, 5. So AC was 5. And then now DB, well, for DB, I have to actually do a slope triangle because they're not on the same level. So to go from D to B, I go down 1 and I go over 1, 2, 3, 4, 5, 6. So 1 and 6. So DB, it's the square root of 1 squared plus 6 squared. So 6 squared is 36 and 1 squared is 1. So this is the square root of 37, which is about 6 something. So 5 is not equal to 6. So my diagonals are different. So opposite sides are equal. Different diagonals. Therefore, it's going to be a parallelogram. Okay, so y'all, like I said, you can either, I'm going to write it down here, find the lengths of the sides, find lengths of diagonals, and then compare that with the chart that we gave you when we learned this. Okay. This was back at the beginning of March. Yeah, it's in the week 3-1 stuff. Okay, or you can use the slope and the midpoint and stuff like that. All right, so that's a quick rough review of all the stuff we did with quadrilaterals and polygons. I know it's a lot. I appreciate you for staying here through the whole video. If you have any questions, please reach out to your teacher and let them know. And good luck on the district assessment. See you guys later.